also has some questions about like the high clouds profile. It's a lot easier to see on this than all the other stuff we would.
Yeah. And I think we could have generated this on there, but
Yeah. We should have just used this one. It definitely was all right. We just didn't click on it.
yeah. Next time.
Yeah. If we would actually go to like upload board, all I need is this.
Yeah. Oh, this one's not as pretty.
But that was the thing.
Great, thanks, Pete. Yep. Welcome, everybody, to our weather discussion today. We've got some interesting things to talk about. I think hopefully we're gonna devote more of the time to the forecast for reasons that will become clear in several minutes, and to your delight. But here's the pseudo visible image movie, I should say, for the last several hours over the continental United States and adjacent waters. Couple of really interesting things here. I'll start on the East Coast. First, a very impressive storm over maritime Canada with a cold frontal cloud band extending all the way into the Lesser Antilles in the Caribbean. So, enormous scale to this disturbance. Within the context of that, there's this new development right off the Carolina coast, which looks perhaps a little bit innocuous, but it's in an unusual spot. It's really, for this kind of period, I mean a life cycle stage in the development, this is an unusual storm, and it's heading southeastward, which is really interesting. We'll try and figure out some elements of that development when we look at the upper level charts. Then we've got Hurricane Sarah just north of the Yucatan Peninsula, or just to the west, the east of the Yucatan Peninsula. I forget now, I haven't looked at what the forecast for it is, but earlier this week, of course, it went right through the Straits of Cuba and then into central Florida at sea level pressures below 950 millibars. So for the middle of November, for that to even be a threat in a reasonably short forecast period is unbelievable. And it's about to hit a state populated by people who don't think there's anything happening to the climate. So maybe that's this whole collection of states, but it's certainly that one. And they're the ones under the gun. And so my guess is that right now this thing is probably a little bit further to the south and west than it had been anticipated to be. And perhaps that means it won't be a landfalling storm in the United States. Honestly, I don't know that, and I'm sorry I don't have that information, but states like Guatemala, Nicaragua, they're gonna get heavy rain, and that's not good. These places, you know, there's no place on earth that can take the kind of rains that come from these kinds of storms, or in Valencia 2 weeks ago, 30 inches of rain in one day. Okay, this is unbelievable what's happening in some of these cases. We finally have the clouds clearing out over us. Beautiful sunny afternoon for us, and even with the clouds, the temperatures have been so mild for this time of year. It's just remarkable that you wake up and the temperatures are in the low 40s, and it hasn't gotten below freezing. I honestly don't think we've had a frost at my house. I have this one plant in the back, one of the herbs that my wife grows, and I think it's got kind of hairy leaves, and so one day I looked out, it looked silvery, but I think it's just the hairy leaves, not the frost. My tomato is still going, amazingly, in the middle of November. It's become a recurring theme. I still haven't had my ceremony. I don't think I will till next weekend. So just incredible. Finally, two more things. First, here's the snow from last Friday when we were discussing it as a forecast potential. That snow is still hanging around in the lowlands of eastern Colorado and far northeastern New Mexico, where they had, you know, between 2 and 4 feet of snow, depending on exactly where you are. And that was well forecasted, as we might recall from last week. And then look at this open cellular convection that goes all the way down to the southern tip almost of the Baja California Peninsula. This testifies to an unusually southward excursion of very cold air. And that probably means, and we'll see in a minute that it does in fact mean, a very low latitude upper trough. And that is unusual and has some repercussions for us weather-wise in the early part of next week. I'll let Patrick talk about that if he so chooses. There are other things with which one could spend one's time, as you'll see in a minute. So those are the broad features. I think when you look at the map from the perspective of having identified a few of them, one gets the impression that it's a fairly wavy flow across this part of the Western Hemisphere right now, in the mid-latitudes, and still in active tropics. And so whether or not those two spheres kind of influence each other over the next several days is yet to be determined. It's not certain. I haven't looked at that particular aspect of the forecast problem. Okay, so that's the satellite view. Let's take a look at the radar view before we go anywhere else. And you can see just the western fringes of that a shape disturbance, the cyclone off the North Carolina coast, and you can even see within that little piece that it is making rapid progress to the southeast, which is just unusual. One imagines upper troughs tending to be caught in a flow that drags them poleward. The cyclones go poleward as well, and that maintains the jet in the long run. But this is a little bit of a unicorn in that regard. A little bit of precipitation over maritime Canada and eastern Maine, where just about nobody lives. If you ever drive up there in Maine, you can go 50 miles without seeing another car. It's really amazing up there. Beautiful part of the world. And then some precipitation over the far west, Nevada and California. And we'll see that that's an association. It's speckled. It's not really well organized. That's in association with, in fact, the upper level trough that is ushering the cold air southward along the coast, and so the west coast, so you can see that. But by and large, the rest of the country, pretty nice day. And when you're in the middle of November, I was talking to Steve Ackerman today, and we haven't had a cold day yet. And so every day that goes by gets us closer to April 1st. So, that's really one of the goals now for most people, not for me. I want the winter to be really robust every year, but I have vanishing hopes of that as years go by. I just don't think it happens here anymore. I gotta find a new latitude to live at, because I'm not gonna be satisfied in southern Wisconsin, I don't think, anymore. Let's hold that thought. Maybe I'll be wrong, and I'd be thrilled if I am. Let's start looking at some of the upper level charts, Pete. So let's go to the eponymous super Pete's. And we'll start at 500 millibars. Thank you. So here's this morning at 7 a.m. Look at this upper trough off the Carolina coast, or just on the coast actually, at 500 millibars at 7 a.m. The cyclone now is a little bit offshore, and we're now several hours downstream from that. But this is pretty cold air. It's minus 22 over the Piedmont of Virginia at 500 millibars. That's pretty chilly for this time of year. And we got a 75, actually an 80 knot jet at Asheville at 500 millibars. So very impressive, reasonably strong horizontal temperature contrast. It's a small scale upper disturbance, and it's kind of invading the space occupied by a broader scale one, which is the cyclone that you saw on the satellite picture that has its cloud head here over the Gulf of the St. Lawrence and in the maritime provinces of Canada. So this is an interesting feature. I don't have time to do it. I'd like to watch the evolution of this. Maybe we'll just do that in a minute, Pete, just see where this thing comes from, because right now it's spawning that cyclone off the North Carolina coast. It's a small, obviously perfectly named short wave, small wave disturbance, and that's the progenitor of the cyclone off the coast. We, in the central part of the United States, have this broad, flat ridge over us, which testifies to the, downstream of the ridge axis. That's about where the clouds end, is right about there, because it's downstream of here you have subsidence and you erode it, and broad, maybe weak ascent downstream of the trough and over this part of the country. But it's clear because the flow is fairly weak and it crosses a robust mountain chain, which induces subsidence in its lee. So that tends to be, anytime the flow has a strong westerly component, you're going to have a probability of clearer skies and warm air in that particular region. Here's the deep upper trough. Look at how far south you go in California. You're just north of Death Valley, and you're in the minus 20 to 25 range at 500 millibars over the Imperial Valley of California in mid-November. And this strong temperature contrast across that part of the state is on the order of 10 or 15 degrees C at 500 millibars. It's no longer a continuous band of strong baroclinicity. Much of it's been eroded in this northerly flow, and this little portion of it here is the last vestiges of what I think was a reasonably intense upper front in northwesterly flow earlier in the week, and that's carved out this deep trough over California and Nevada. And so remember, we saw this speckled convection off the coast and even inland. If it were convection inland, it's hard to know. It could be ground cloud, but it seemed to be moving. But that's in association with the cold pool aloft and probably the beginnings of some daytime heating over the higher elevation. And so you're seeing a few clouds emerge in that particular set of circumstances. So we're bookended by some interesting weather on the coast. This is an amalgamation of two, one a broad trough and one a very small scale feature, and the other on the west coast, a really deep upper trough, which sets the stage for development over the Intermountain West over the next day or two, and that of course has some possibility of having an impact on us. Meanwhile, here's the Aleutian chain, and there's an intense baroclinic zone at 500 millibars and really strong geopotential height gradient that's more or less zonal, or maybe from southwest to northeast at a slight angle, and very intense winds. We're going to look at this feature in Vis 5D, a little bit of a close-up over the Pacific on that, and then maybe, I don't know, but just maybe Patrick will take a look at the several days in advance in that same region of the globe. There might be something of interest there. So let's go to 300 millibars first, Pete. And you can see that that baroclinic zone at 500 millibars is tied to an upper tropospheric jet, 182 knots here, just south of one of the middle Aleutian Islands. And you know, that's in the analysis. So that's a pretty strong jet. And it's localized. It is mostly in that straight jet configuration. And there is this little appendage that heads southward on the western side of this upper trough. And then we've got downstream of the trough axis over California, the jet kind of re-emerges over parts of Arizona and Utah. Re-emerges is the word I use because, of course, the flow is strongly subgeostrophic here, and when the momentum gets around the base, you can kind of start to see it look a little bit more like its geostrophic value. And you've got 100 knot and greater winds in much of this portion of the west, okay? And 182 knots through there. So to my eye, I'm quite intrigued at wanting to see what this structure looks like through the middle or maybe the entrance half of the jet. We'll do that in a minute. Here's the reflection of our 500 millibar trough currently spawning the cyclone off the Carolinas. And it's got its own little jet streak, 110 knots across, you know, from the southern Ohio, Cincinnati area all the way off the coast of North Carolina. So that's a little stubby jet streak on the western side of a small trough, which means it tends to dig the thing, and that might be why it's headed to the south and east. And it digs it because at the exit region, there's ascent in this left exit region, and that's right where the coldest air already is. So it gets made colder by adiabatic expansion, and the colder it gets, the lower the thicknesses get, and so the heights tend to fall when the thicknesses collapse like that. And so the tendency for the geopotential height minimum is to move to where it's getting coldest most rapidly, and here it's getting colder by ascent. Okay? So that's the broad picture that it looks like over the continent. And let's see, what do I want to do next? I think I want to go right to the let's go back to 500 millibars and point out one thing, which I'll show again.
The loop.
No, yes, the loop, Pete. Let's take a look at that and just stop looking. Remember I did this last week, I'm gonna do it again. Don't look, just go back a couple of times.
I think this might be last Friday.
We don't want that far back. Stop looking, I told you to stop looking. Okay, right here is good. This would be 12Z Wednesday. So what I'm hoping to see is some evidence of how this upper trough evolved in 2 days over the Carolinas. So let's click forward. I haven't seen this, so this is fresh for me too. Ah, there it is. There's a trough. I don't know if that's the one. It is. Son of a gun. Okay, let's keep going. It's minus 22 at the core of that. It's at least minus 20. And then here we are, the next time is right off the coast. So let's go back a couple of times. Maybe a couple more. Right there is when we have an upper trough. One more time, maybe. Here it is. Let's go one more time. One more time. Ah, it is. One more time from this, too. Perfect. Here's a baroclinic zone on the west coast. Notice how it's got these weird little jogs in the isotherms. Those are a function of the fact, I think, and we're not going to take the time to prove it, but I bet I'm right, that these jogs represent, here's a place where the air has been historically subsiding. That's why it's warmer here. Here's another place where it's been historically subsiding, and it's all on the western side of this developing upper trough. So that's a developing upper level frontal zone. It may not get to the really strong intensity that you sometimes get, but these temperatures are in the minus 20 range and colder at 500 millibars, and we're incrementally warming it up on the west side, so the gradient's getting stronger. And there's a region of curvature here, and you can even see some cold air advection in that at the base of the trough in cyclonic curvature, so that's going to help to further bring the tropopause down. Let's go forward now and watch how this goes. It has this ridge across. There's a strong baroclinic zone there that's developing, right? That's on the order of 10 degrees across the state of Nevada, right there. Go again. And then it seems to disappear. It's maybe obscured a little by its passage over the high terrain of the Rockies. And here it is over the panhandles of Oklahoma and Texas. And it remains a pretty sharp upper trough feature, fairly localized region of curvature. It's flat here and it's flat upstream, but it's really strongly cyclonically curved over Missouri and Arkansas. One more time. And then we're in this position where somehow we've manufactured a cold pool of minus 22 over Indiana and Illinois on November 14th. And then it slides to the coast, and it starts to do its job for cyclogenesis. All of it happening while this feature to its north and east has remained relatively stationary over those same 2 days. Okay. Starting there. So this is a fairly independent feature that's gotten into the universe of this, but it's evolved on its own and become a cyclogenetic precursor without any question. So thanks for the movie, Pete. And then I'll point out the cold air advection in cyclonic shear over the Aleutians. And then let's go to Vis 5D. We'll show you a couple of things there that will reinforce some of these points. Okay, and I think we have to put the map back on. I was fooling around with the color. Thanks. So here's the map. This is the Pacific Basin, and we're looking at the GFS model initialized at 6Z last night, so about midnight our time last night. And here we go. So here's the 500 millibar flow. You can see it's largely zonal and almost parallel to the sort of tangent point of the Aleutian chain. And then let's put theta on top of that, which is right there. And here's the potential temperature at 500 millibars. Warm air advection into the ridge just off the British Columbia coast, but obviously strong cold air advection right in this portion of the, and notice that the shear is cyclonic. Here the geopotential heights are tightly spaced, here they're weakly spaced, stronger winds, weaker winds, cyclonic rotation. So there's cold advection by the geostrophic wind and cyclonic shear. Let's take a vertical cross-section through this thing of potential temperature first. So right through, you know what, Pete? Before we do that, let's look at the PV. Yeah, so here's the PV. This is the 2 PVU surface. Here's our upper trough off the California coast, which is currently now getting something organized at low latitudes, unusually low latitudes, over northern Mexico. Here, and blue represents a very high level for the 2 PVU surface, and the red represents a really low level. So we're talking about a deep trench in the tropopause, right here along the Aleutians, right where we saw that strong zonal flow at 500 millibars. So we can take this off. I just wanted to put it into context for the time being. And let's flip this up and look at the vertical cross-section of theta. And there it is. That's potential temperature every 3 degrees Kelvin. This must be, I don't know, some ice or something. I forget where exactly we end up in the cross-section, but look at that intense baroclinic zone. Comes all the way down to the ground. So this is a deep tropospheric front. Has its foot on the ground and its head in the stratosphere. So this is really intense. Let's put the PV cross-section on there. So that's PV right there. This is potential vorticity, and you can see a fairly steep wall of PV right at the front edge of this thing, and then this pendant of PV that comes all the way down to, this was 500 millibars, this is maybe like 600. It's pretty deeply penetrating into the upper troposphere, but it doesn't go all the way to the ground. And then, let's put the wind speed on there. Take the PV off, I guess we can do that. Here's the wind speed every 10 meters per second starting at 30. So 30, 40, 50, 60, 70, 80 meter per second, 160 knot wind speed max right in that location. So there's the jet core, 452, 751. We've been talking about the influence of geostrophic cold air advection and cyclonic shear and what it does to the vertical motion field. Let's put the vertical motion on top of this. Right there. Oh, son of a gun, I'm only showing the descent. It's right through the jet core, just like we were talking about in class. So, and what's that doing to this bundle of isotropes? Pushing them down differentially right here. And that's where, if you take that off again, Pete, quickly, here's your subsidence. That's where your upper front is. It doesn't do much for the surface front. That's controlled by something else. But the upper front part of this baroclinic zone, if you can put omega back on, Pete, is definitely controlled by this subsidence through the jet core. Andrea's not here, but she's talked about lower stratospheric fronts, because above the jet, there's another front. You can see the baroclinicity in the isotropes here. Subsidence here is eroding that feature, but it's increasing the intensity in the underlying troposphere. And that's actually what we saw in several cases, that the stratosphere and troposphere trade off often in terms of what they're doing to the baroclinicity. So when the upper tropospheric front starts to get intense by this tilting, the same exact thing, the opposite is happening in the lower stratosphere. And prior to that, the lower stratospheric fronts get intensified. So pretty neat, although we don't know if that's characteristically the case. So that's a really nice interrogation, thank you, Pete, through this upper front feature in the Pacific Northwest, or the Aleutian Islands. That is all I'm going to talk about in the current weather, even though there were other things to investigate, because I want to preserve the time for Patrick. And I will give a little bit of let the cat partway out of the bag. Interesting though this is, it's not the feature of interest in the future. And I think you'll see in just a minute what is. And I'll help you, he can help you through Vis 5D, but do your own discussion first, and then we can look at some of those things in Vis 5D.
Sure. Perfect.
Okay, thanks.
Thank you.
Could we go to tropical tidbits, please? I'm not going to talk about what's going on over the continental United States, although there's going to be an interesting storm that develops in the Central Plains and maybe gives us snow into next week. But let's go to the Pacific, please. And I'll do the North Pacific. Perfect. Okay, so this is, let's see, this is tonight, valid. So we see a system over the Central Plains of the United States. Here's a storm in the Aleutian Gulf, which is bringing a lot of hazardous weather to Alaska. What it's mainly doing, though, is as it developed, which we can't go back on this specific time, this specific website, but you can see it sets up this nice baroclinic zone over the northern Pacific, which is important for what I'm going to talk about going forward here. So if we could step forward.
And that's the one we were just talking about with the cross sections, yeah.
Yeah, this is the baroclinic zone that we were just talking about. If we could go like a couple clicks forward, maybe to 0Z Saturday. Wait, these times are old. Could we refresh it? Maybe that's why I'm not seeing.
I did refresh it, but it's good.
This is runtime the 8th, yeah.
Oh, there we go. If we just click the first one, keep going up. That's why we weren't seeing it here. 12Z Friday. Okay, perfect. Here we go. Here's about right now. Here's that baroclinic zone that we saw, and the storm over Alaska, which is forcing, interesting weather there. But what it's doing, you can see on the backside of it, it brought down all this cold air represented by the blue thickness lines all the way into the North Pacific. This is going to be a feature of interest that we'll watch. So if we can step forward, let's go like to 18Z tomorrow. This is perfect. So now we can see that storm sits over the Alaskan Gulf. It's continuing bringing down, if you follow these isobars, they're a little exaggerated because this is a tropical site, so they're every 2 millibars. But you can see there's an intense wind gradient, pressure gradient. All this is strong cold air advection, and we develop this high pressure along this baroclinic zone, which is something that I'll note. We can step forward, let's go to 18Z Sunday, and we'll watch this evolution. The storm keeps sitting over the Alaskan Gulf Coast. Here's a system that it's 1,012, but this is going to be the start of what might become the strongest storm to ever hit this part of the world. I don't know if that's for sure, but we can look at some things that might indicate that this is going to be the strongest thing to ever hit this part of the North Pacific. So watch this storm here, 1,012. It has a nice cutoff in the thicknesses, so it's a cold core, the blue circle around it. And we'll watch this out ahead of it along the baroclinic zone. If we go 2 or 3 clicks forward, now we have something interesting. Let's go back 1 click, please. We see there still is the cold core from that upstream cyclone, but we developed this cyclone just directly on the warm side of that baroclinic zone. 1 click forward.
That looks familiar.
It does look familiar. We have a nice precipitation maximum, and you see it we have a cyclone sitting to the south. There's sort of a T of precipitation. This precipitation is situated right along that baroclinic zone that the Alaskan storm helped facilitate to bring down to southern latitudes. Can we take a cross section north-south right through the precipitation maximum, please? And we'll do PV. There we go. Okay, so you'll see this looks nothing like the cross sections we've seen before. However, right here, we have a surface maximum in PV. This is situated right underneath all the precipitation. So we have a bunch of clouds forming precipitation, a lot of latent heating. You erode PV above and generate PV below. This PV near the surface can intensify and develop its own vortex structure. This is what we're seeing develop right along this baroclinic zone. And this becomes its own sort of propagating feature. It's its own vortex. If we click out of this cross section, so we have a lower level cyclonic anomaly. You have cyclonic flow around this precipitation maximum. Out ahead of it, you have positive frontogenesis. You're going to keep increasing the rising motion. It's going to continue to propagate to the east, and it becomes its own feature. You see, you can kind of get a hint of it from the thicknesses, but we'll look at a 500 millibar chart. This is completely in the lower troposphere, and we saw it was in the lowest 100 millibars of the entire atmosphere. Let's go to upper dynamics, and we'll pull up the 500 millibar. Oh, they don't have it, that's right.
And sea level pressure, you can do that. maybe.
Yeah, we can do that. That's perfect. You'll see, so here's the trough feature. This is just completely by itself. We have a nice block setting up over Alaska and parts of Russia. Here's the feature of interest though, completely divorced from anything. If anything at all, it's kind of situated in a small ridge as represented by the color fill. So let's go back to the precip of moisture and we'll watch the evolution of this. Here, let's go like 2 or 3 clicks forward. We're at about 1,010 or so. Let's go 1 click. See, not a lot has changed. This feature though, you still have precipitation maximum. You have that associated cyclonic flow. It just keeps moving along the baroclinic zone to the east. Now here we'll start the interesting story. So we're at 0Z Tuesday, November 19th. This is only 84 hours in the future, so this is not exactly in fantasy land. This could happen. We're about 1,010 millibars at the center of this cyclone. Let's go 1 click. Now, I don't know exactly what the pressure is, but you can see there's an intensification. Stronger gradients between all the isobars. You can see now we're distorting the baroclinic zone along which it's forming. You're forming a thermal ridge and a thermal trough behind it. 1 click forward. Now we're at 985, 1 click.
So hold on though, that's
Oh, yeah,
26 millibars in 12 hours.
That's right, 26 millibars, 24 hours.
26.
1 click. 985, 1 more. 968, 1 more. 947.
That's 38 in 12 hours.
That's 38
Added to the
in
26 is 64 millibars.
64 millibars in 24 hours of this development from a feature that started near the surface. We saw that it was that little PV perturbation becomes a 947 millibar storm, and this is close proximity to land. So this is not just sitting over the Pacific, it's actually impacting coastal regions of British Columbia, Washington, Oregon, California. And you can see, if we just go back 4 clicks, so at the start of the storm, seemingly from nothing, we had this development where you have pretty quiescent, just light rain. 4 clicks forward. All of a sudden we're in this, dominant storm feature where now you can make out the fronts within the thickness lines. Strong precipitation maximum based on the color fill. This is like 2 to 4 millimeters per hour, which I'm not exactly sure how much that is, but very strong winds associated with this. This is going to cause a lot of damage, even if it's not even this impactful for the portions of the western North America. And if we could go back to 0Z, we'll look at this at 500 millibars, because it's also interesting here. So at the start, here's our precipitation maximum, our dieback Rossby wave sitting at the surface. Let's pull up that, yeah, that'd be perfect. And you can see, so now we have upstream ridge, maybe some indication of an upstream trough, but well to the north of where this actual storm is located. It's largely zonal at this time. 1 click forward, please. You'll see now we begin to develop some indication of a trough based on the color fill. 1 click forward. Now we're definitely developing a trough. You can see the axis is directly upstream of where the cyclone is sitting. 1 click. Now we're situated right where you would expect. Here's the trough axis. Right downstream is where the cyclone is situated. 1 click forward. Now we're at 947, and we're completely within that trough. And down upstream of it, you can see a very big ridge blocking pattern. It seems as you have a high over low, directing the flow way to the north and then way to the south on its downstream side. And there's one other thing. I think if you go to lower dynamics, I believe, I did have vorticity on here at one point. I'm trying to remember how I did that.
Yeah, I don't know either.
Let's see, we can look at the PV with this as well. Maybe I can see that. If we go back to just 4 clicks. This all happens in a day, by the way. So here's this is along the baroclinic zone. You can see the purple contours. That's cyclonic vorticity near the surface. So it's directly along the baroclinic zone in a zonal pattern. And here's the upstream ridge beginning to form. If we go 1 click, you'll see this is our storm. It's still largely separate from any upper level forcing, especially this is 330 Kelvin PV, so this is PV pretty high in the atmosphere. It's still situated at the surface, but it's still undergoing decent development at this time. 1 click. Now we get situated, we're right in that downstream side of the PV that extends all the way down, towards the equator. You can kind of make out we have a little bump, or where the PV erosion is occurring due to all that diabatic heating. If we go one click forward, you'll see that becomes more apparent, where here's our trough in the PV, and then there's that diabatic erosion happening, and one click forward. Then we're situated right where you would expect. We sort of have that treble clef in PV, where you have all of this diabatic heating is eroding the PV in the upper levels, and you can see that from the 330 Kelvin PV. This is all happening, like I'm saying, 24 hours. And all it starts from is a nice precipitation maximum in the lowest, 100 millibars in the atmosphere. These are called diabatic Rossby waves. They first were discovered or theorized in the 1990s, but 2011 was the first time any of these were actually studied extensively. And it turns out these happen, there was like a 10-year climatology, about 10,000 of these happen over 10 years. So these things happen all the time. What does not happen is you create a monster 947 storm out of one of these things. So there needs to be favorable phasing, otherwise you can imagine you just have a lower level vortex, it moves along the baroclinic zone. If you don't have any upper level forcing, it's only going to strengthen so much because it still needs extra oomph to go into a 947 storm. Otherwise it's just going to be one of these, maybe 1007 or 1008 storms. Nothing like what we're seeing. And this, you can see the proximity of this storm to Washington, Oregon, and British Columbia here. If we could go to the link I sent, please. So there isn't, to my knowledge, a nice climatology of the lowest pressures over the Pacific. The closest thing I can find is if, from this page, if we go to the all-time lower 48 low extremes, and if you look up here, this white contour is 54.2 millibars. So if our storm is situated, right near this contour, this will be the all-time lowest pressure record for that location of the Earth. It's not clear to me that, if this is going to be, first of all, this is going to verify completely, but if this storm, if these contours extend further in the Pacific, I'm not sure, but this is definitely a notable storm for this part of the country, nearing all-time low pressure records. This storm also, so it's not 63, 64 millibars, 24 hours is not the all-time lowest deepening. That happened in the Atlantic, and that was 78 millibars in 24 hours. So even more extreme than this, but this storm nears that, and it's happening on Tuesday. The other storm happened, a long time ago. So this is really relevant and very interesting. And if we go to my last thing I want to show, if we could go to, I think it's COD weather has this. I don't know if it's up. Because I want to show how anomalous this pressure will be for this part of the country. And this is the GFS model, by the way, that's showing all this. If we go to weather data, and numerical models, and then we'll do GFS again. And if we could go to, I think, Pacific Ocean. Maybe it was this I was showing. And then if we go to surface, and standardize mean sea level pressure anomalies, we'll watch the same evolution here. So let's get to Tuesday at 0Z. So we see the same evolution here. Okay, perfect. Here's our storm. You can see the extension of lower pressure. This is all due to the ascent column stretching along that baroclinic zone and as a function of the lower level PV vortex. So let's go forward and watch this. The red colors mean it's too low of standardized anomaly. We'll keep going here to 0Z Friday. There we go, very obviously low outside of the record. If we hover over that central point, keep going up to the left a little bit. There we go. So it's about 5 sigma outside of climatology. So you go 5 standard deviations away. This is how extremely anomalous this storm is for this part of the world at this time. You can see the mean sea level pressure 1011. millibars, and this is about 948, 947 millibars. So that's how extremely anomalous this is. This development is and is going to be. Whether it gets this deep or not will be something to watch, but there's going to be a significant development regardless, and might reach 5 sigma outside of standardized anomalies for this part of the world. So, very interesting. This is happening, right before our eyes, essentially, and might set low pressure records. That'll be something I can look into further if this does set a low pressure record for this part of the world, but I just couldn't find that in the time that I was preparing here. So we can now, if you want to cut cross sections or do stuff with Vis5D with this, if you want to.
Yeah, we can, you mind if I help?
Yeah, yeah.
Yeah, okay, let's go back to the plan view. That was great, Pepper.
Yeah.
Stick around, though. You're gonna learn something. Okay, so let's march forward till we get to Tuesday. I think that'll be encompassed in this. Now, it's a slightly different forecast. Yours is
Okay.
12Z, mine's 06, but I think the thing still shows up.
It should,
So-
yeah.
And let's see, there's Tuesday 0Z. Let's clean this up a little bit. Take the pressure and theta off. And let's put mean sealable pressure on so we can get an idea where we are. Okay, I think this is probably the beginning of that development in this particular forecast run. So let's go ahead a click or two and see if that turns out to be right. Oh, there it is. Okay, it's a little bit anticipated. That's the big storm. Do we have any more space we can go? Yeah, 1,000. What is this now? I'll count it out for you once we get there. I think we can go a couple more.
Yeah, that's the lowest pressure.
Okay, let's go there. So this is 1,012, 8, 4, 0, 6, 2, 8, 4, 0. That's 980, 76, 72, 68. So it's in the range, but it's not quite as intense.
Yeah.
It's not quite as intense in the simulation. So let's do this. Let's take a look at what the PV looks like on the tropopause this time. Yeah, what is that sealable pressure?
I'd have to move it to the ground.
Oh, yeah, okay. That's okay. We don't have to do that.
What do you want?
PV in the, there we go. Yeah, so then we'll tilt it up. This is the big upper trough that Patrick was pointing out, and it's got no really deeply sticking down appendage. And this was interesting to me in the context of what you talked about, because you're so right. This thing starts out as a diabatic Rossby wave. Here's the lower tropospheric PV as it shows up, but it's nowhere near this storm. So this thing started out that way. I think you're right about that. I'm not going to spend the time to prove it with this simulation since it's different. But by the time it gets to this remarkable depth and goes through the remarkable deepening, it's all upper levels. And that's the cool thing about it. And it might be quite like what you had in November 2019. Not sure about that. Let's take a look at the vorticity, and we'll go back maybe 4 or 5 clicks so we're not in the period when it's already here. How about right there is great. Maybe 2 more, Pete. I'm sorry I keep changing my mind. These are every 3 hours. Let's go to 6C Tuesday, go back to the top view, and we'll take the PV off. Here's the original cyclone, the cold core feature stays there. And then this new thing develops, and this is it actually in this simulation. But let's take a look at vorticity in the horizontal cross-section. I'm showing you 500 millibar vorticity every 4 units, starting at 12. So this is 12, 16, 20 times 10 to the minus 5. Here's the main upper vortex feature that's going to be coming through here. Right there. That is 12, 16, 20, 24. 2.8 times the Coriolis parameter. And it's in exactly the right position that is slightly up shear of the cyclone for the development to occur. Let's click ahead of time. Look at this incredible strip of values over 2.5 times the Coriolis parameter. There's our cyclone one more time. There it is, a big strip of vorticity. Let's take a cross section through here. I haven't done this yet, Pete, but let's do it. Let's, yeah, first we'll do theta. Maybe you can just move it to that and it'll keep that orientation, in fact. Yeah, you gotta find that middle point somehow by magic sometimes. That's perfect. Let's do that. And let's see what that looks like. So there's a really deep baroclinic zone. It comes right down to the ground. It's tied to this cyclone, no question about it. Here's a big upper PV feature, and then there's that. And let's put the PV on top of this cross section too. If we can go back to the top view and slide that one over. About right there was about where it was, right? See what that looks like.
Is there another one you're gonna want? Omega?
Probably not going to want Omega. No, I don't think I'll want Omega. So that might be it. Oops. Let's tilt that up. And so here we've got another deeply penetrating upper tropospheric PV feature. This, remember, is at 5.4 kilometers, so this is down to something like 4 point something. So that's like 600 millibars. And then, oh, let's take a look at the top view again. And let's get rid of the sea level pressure. We know that cyclone center is right there. I'll keep my pointer there. And then let's put on theta in the horizontal. And it's gonna have to change color. Let's make it yellow or something so it's a different color. Cyclone's right here. This is a proxy for the thermal wind. It's 500 millibar approximately theta. But it's a really strong thermal wind here. We saw that in the cross-section through the strong upper front. Here's the maximum in the vorticity. Here's the cyclone. This is strong PVA by the thermal wind fueling this development at this point. And the question is, where does this feature come from in the upper vortex structure? And it comes from an upper front. And not sure about the history of that, and I won't spend the time to look at it now, but it could be an interesting story. So many elements of this are just like the storm you're looking at, where it starts out as a diabatic Rossby wave, it leaves its parentage in the dust, heads off to the east, seeking fortune, and then finds an upper front that comes along and says, no, you're not gonna stay this wimpy, you're gonna turn into this beast, and it's a function of PVA by the thermal wind. Let's go a click ahead and see if that continues with these two variables. So here's the vortex max. Now it's like 4 times the Coriolis parameter. Still an extraordinary thermal wind there. The cyclone's right here. Let's go again. Look at that. Balled up. Here's where the cyclone with the strongest PVA is. And let's just for the fun of it, Pete, where's the sea level pressure minimum at this time? Well, son of a gun. It's right over that. So it's no longer really feeling the propagation from this PVA by the thermal wind, but this is an even deeper storm at that time. It's sitting right on top of it. Here's the upper baroclinic zone. I think I had theta E. I'll do one last thing. And there's the lower level baroclinic zone. So it's just perfect, isn't it? What an intense structure. So if this happens, it's going to be fun to see this next week in retrospect. So, yeah, very cool. That's all I wanted to say. So,
Yeah, thank you. And then last thing, since we have like 1 or 2 minutes, can we go back to tropical tidbits? I'll just show what I was showing, and then let's go to regions. Let's get it back on there. CONUS, and we'll do precip and moisture. I'll point out, maybe we'll get some, and can we do the frozen one? Actually, yeah. And let's step back. Okay, so you see interesting development over the southern plains, like I pointed out. Let's just keep going forward. You'll see it moves over our region, rain, keep going. You can just keep clicking here. We'll watch it. This is the first wave. It sets up a baroclinic zone. Like the storm, it pushes it south. We get another development from something that another upper level trough comes through. And earlier in the week, and maybe even just earlier today, this cyclone was situated closer to Michigan, so we were in this region where we might see some snowflakes next Thursday.
yeah, amazing.
From this storm. But this this model run, first of all, you can see, look at the precip shield wrapping all the way back up from the cyclone all the way down into Cuba. Snowing up here, raining down there, same cyclone. You can see a lot of cold air infiltrating all the way down in the eastern United States. If it snows in New York before we get snow, that will be very disappointing. If it snows in Virginia before we get snow, that will also be very disappointing. But there's a chance that we might see some snowflakes. And if we keep going forward just a couple clicks, I think there's lingering snow showers with this push of cold air, a lot of lake effect. So this might be the story for next week, because you're going to have a lot of lake effect in the lee of all these really warm lakes. First push of really cold air over the eastern parts of the United States. Unfortunately, the winds are going downstream of us, not the other way. So if the winds were somehow reversed, we would be getting the lake effect, but we're not.
You're really trying, aren't you?
Yeah, I know. But it doesn't look like anything substantial at this point, but something to watch. We might get some snow. And here's the storm, or the remnants of the storm. It sits over the Pacific and stays strong. You'll have rain and snow in the western portion of the United States for a couple of days. So those will be the weather stories for next week.
Yeah, and if we can go back a couple of clicks, the interesting thing about the precip shield, keep going back, I'll tell you when.
Oh yeah.
Like maybe a couple ahead of this. One more, right there. It's snowing to the south of where it's raining.
That's right.
That's unusual, but it happens sometimes.
That's right. Mm-hmm. Yeah. Anything anybody wants to see your questions? Yeah.
How do the
this storm specifically.
Yeah, because if you go back to the PV, like, it looks like, I don't know, there's some sort of impact like this.
Could do like this one here. There is a PV anomaly that comes down, and your cyclone and development is situated just downstream of this.
Yeah, that
All
comes from
PV.
higher latitude.
Yeah,
Yeah, so does the, like, diabatic erosion from the cyclone that was upstream help, like?
Oh.
Yeah.
I see what you're saying. Let's step back. It looks like maybe, however, this storm is, pretty far removed from where this PV appendage is. This can happen like in the other storm, but for this specific development, it seems like you have a cyclone develop and move over the Central Plains. It largely weakens. All it's doing is bringing down a lot of cold air, and then you get a separate push from the upper levels that's to the west. And then you can see if we step forward here, you'll see here's our new development. And there's not really too much erosion. Maybe you could argue there's some that cuts this off, but in the direct vicinity of this PV anomaly, not really.
There may have been
This
some,
one.
though, from the upstream storm in the Pacific, the one that we spent a lot of time talking about. Right at this time, you could imagine this is kind of an amorphous positive PV blob over the northwest. If we click ahead, maybe the western edge of that gets sharpened by the erosion that's going on for
Oh.
that storm off the coast. Is that what
I
you're
see.
thinking about, Ellen?
Wait, and so did that, a similar thing happen in the case that you are like analyzing, did that at all impact the downstream, like, sort of environment over the United States?
In a way, I think,
Yeah.
I can speak to that because I'm working on that part of the problem right now. There's a really intense cyclone in the Bering Sea in that case that Patrick's looking at. It has a really intense warm front and a big thermal ridge that's kicked up in that development. And the baroclinicity that's left behind from the warm front, one portion of it turns into this upper front.
Yeah.
And then it looks like the PV distribution that this thing has just before it goes to town. So there may be some similarity there. Yeah.
No
I see.
doubt they're connected because they're in a train, so
Yeah,
something
right,
happened.
right.
Yeah.
And is that because, sorry,
You're
is that
good.
because there's like Rossby waves that are like generated from like that diabatic heating anomaly that kind of like disperse and that creates like a wavy environment for the rest of?
There can be, otherwise, if we go back to the regions and pull up the Pacific, again, North Pacific here, and we'll get an upper level look. If you see, what sets up, if you step back, please, so here's that big block that sets up. What happens is you'll get trains going over this, and they'll be, if we step forward now, let's go to where our storm is really strong, Wednesday. You'll see now there's a preferential storm track to go up and over this and down towards the south. Here's the PV appendage, eroding PV, and exactly right. It's eroding due to diabatic heating, and here's the one that forces our snow potential. So it's eroding this. If we step forward 1 or 2 clicks, yeah, you can see there's nice erosion, and it helps in this PV anomaly becoming cut off and then moving to the south over the United States. But largely what happened is this big block is just steering the flow up and around it, and then you get these shots of upper level troughs, PV anomalies, everything down towards the west. And that seems like what's happening here.
Yeah, and then maybe this wave over Alaska is going to break, and that'll just crush all of
Yeah,
all
look
the
at this.
production that it's done downstream. It's just going to level all of those PV anomalies.
Exactly.
But not the one farthest east is the one that affects us, and it's in the clear.
Exactly.
But that feature off the coast is going to be crushed.
Yeah, good question. Anything else? Yeah.
I was wondering, have you looked at UW-AOS? The model has like the same evolution and also like the AI models, because like moving into the winter season now, I'm wondering if like the operational forecast of those AI models can capture such an exceptional stuff.
Good question. We can look at, if we go to global, we can switch that quick.
Ooh, 962.
Let's step back 2 clips here to get to 0Z. Let's get 0Z.
It's almost the same.
So it's pretty close to
Yeah.
the same strength.
What about the evolution? Let's go back
Yeah.
and see the 1 day ahead.
It's every 3 millibars, but it seems like the same. You have zonal flow in the upper levels, and as this develops and moves off, you get this troughing and slight erosion up ahead, and
Yeah.
it looks pretty close. Just magnitude's off.
Look at the AIFS, I think it was on the list of the global,
Okay, yeah.
because that's also horizontal, so I'm wondering.
Wow.
pretty close in magnitude. So this seems like this development is gonna be a done deal. The pressure, the minimum pressure is what's not exactly hashed out yet, but it will be significant for this part of the world.
Wow.
Does the AI model?
That's a good question, that's surprising.
Does it what?
Does it show PD?
Let's see, maybe.
No.
No. So that's one hindrance, but most likely if you have the same sort of evolution, you'll have a similar PP structure. I would think so too.
Wow, interesting.
The AI model, I just looked, like the AI model, and yeah, this is like 11 days out. But it's saying like there could be a high here of like 15 degrees, and I'm like, I don't buy that. Unless there's a really, really massive Arctic air mass that just moves down.
Yeah, it doesn't seem like it from this.
The heights are in the 490 range in northwest of this whole big ridge in the Bering Sea region, so there's cold air. It's been manufactured, it's just where does the invoice say it's going?
That's true.
I'm not sure of that.
Yeah.
Cool.
All right. Thank you both.
Thank you, Patrick.
Yeah.
Thanks, Pete.
That's great.
I'm sorry I busted into
No, no,
the
no.
office of the news of the day.
I know.